Hi, now we're back here inside the Space Food Laboratory here at the NASA Johnson Space Center. And again, earlier we've been talking about some of the preparation and talking about food and some of the menu items that the crew aboard the International Space Station will be having this Thanksgiving. And again, we are here with Vicki Claris, our NASA food scientist. Tell me, this is just another area of that food lab, so tell me exactly what area are we in right now?
Okay, what you see behind you is our packaging room. And so it's really a commercial portable clean room that we've converted into a packaging area. So all our packaging equipment is inside. It has HEPA filters that filter the air to help keep the contamination possibilities down when we're packaging food. And so the type of food that we do all our beverages would be packaged here, like we have in this package,
Okay.
and all our freeze-dried items, as well as our bite-sized products like M&Ms, cookies, crackers, candies. All of those items would be packaged in the equipment that you see here in this facility.
Okay, great. And so tell me a little about the packaging. What do we have? What kind of packaging is this?
The beverage package, all of our beverages are in powdered form. And so this is a foil laminate pouch that we buy from a commercial manufacturer. We buy it, it's sealed on 3 sides, it's open on this end. We weigh in the appropriate amount of powder for a single serving, and then the packaging equipment that you see here is designed to seal the beverage adapter or the septum adapter assembly into the end of the package. And so this is what allows the water to be injected on orbit using the rehydration station. Inside this is a septum, and the septum is a little plastic valve. So the needle inserts and the water is injected, and then when the needle is withdrawn, the septum closes off to prevent the fluid from flowing out of the package.
Okay, great. And then they just take this and shake it up, and then
you're going to insert a straw, into the package and drink through the straw.
Okay.
And the straw has a clamp on it so that in between sips they can clamp it closed to prevent the fluid from flowing out.
Okay.
The rehydratable products all require the addition of some amount of water prior to consumption. Has the same septum adapter assembly. In this case, they inject the water, they wait for the product to absorb the water, then they're able to cut the package open with scissors and eat out of the package with a fork or a spoon. Typically what they'll do is cut an X across the top. They'll eat out of the center of the X, and the flaps from the remaining material will help hold the rest of the product inside the package while they extract the bite that they're going to eat.
Okay.
You're depending on the surface tension of the wet product to cause it to stick to the package or stick to your utensil.
Mm-hmm. So there's no turkey carving up there. It's just
No.
the scissors, and they cut it open and eat just as that is. So talk to me a little about, so this is what he is doing actually. Right behind us, there's some packaging now. Can you tell me about how long in advance do we typically start to prepare food that's going to be flown into space?
Well, we have to maintain an inventory of our products at all times. And so typically we produce like our thermostabilized products, we'll produce those year round.
Okay.
Because it'll take us an entire year to produce all the different kinds of thermostabilized products that we have. Beverages, we're going to package those usually as needed. And so typically for a ship set, for beverages, we'll start packaging those about 4 or 5 months in advance of the time that the shipment is going to actually go out the door.
Okay.
And rehydratables, usually we try to package those within about a 6 or 8 month period prior to the shipment going out the door.
Okay, great. So this is the packaging, but talk to me a little about the packing. How is this food packed to go up into the International Space Station?
Well, we have a couple of different options for actually the containers that we use to send the food to orbit. One is a collapsible metal food container. Typically we use that when we're sending food on the Progress, because the Progress has slots built into it that hold those containers. Another option that we often use is what we call our bulk overwrap bag. It's really just a large plastic bag that we overwrap the contents of one of those metal containers in.
Okay.
And we're typically using that when we're sending food on the ATV or HTV.
Okay. And these are cargo ships of the different agencies.
Right, yes.
So we have the Progress is
unmanned
the Russian
cargo vehicles. Yes.
Right. Okay.
Okay. And now with SpaceX, the new commercial cargo carrier,
Right.
we're also using the bulk overwrap bags, the plastic overwrap bags, which I can show you later.
Sure.
And they take those and actually put them inside of the crew transfer bags or the MO2 bags, the different, we have an example of one in there in the lab as well.
Okay.
But they typically take those bulk overwrap bags and stow them inside another container to get them to orbit.
Great. Okay, now, as you know, we've been answering some questions from Twitter that we polled, and thanks to our Twitter followers for sending us these questions. Now, one of the questions, and this kind of talks about the future space food system, so I'd like for you to kind of go on and talk to me a little about what technologies we're exploring for a space food system, because obviously International Space Station is one place, and then there are further destinations that we'd like to go,
Right.
and we need food to sustain us for longer periods of time. One of these questions are, given a true space galley, this comes from Todd Templeman, what's the most useful edible we could grow in an attached greenhouse? Thanks.
Okay, so there's two ways to look at that question. In transit, if you were, say, on your way to Mars on a 6-month mission, which now we know it'll take, with current propulsion, it'll take about 6 months to get there, you could grow some crops during the transit. But typically those would have to be what we call pick and eat crops, meaning something like a cherry tomato that you could grow, you could harvest, and basically all you'd have to do is clean it and eat it. Because in microgravity, you're not really going to be able to do a lot of elaborate processing of crops or elaborate cooking, because without gravity that gets very, very difficult. So it's not really practical to think about growing wheat in microgravity and then having to mill it into flour. That's not going to work in microgravity.
Sure.
But when you get to the surface of the moon or Mars, and you're on the surface where you have at least partial gravity, you can certainly then begin to think about the possibility of either growing crops to help you recycle your air and water, and then also using them as part of your food system. Or also the possibility of taking like bulk ingredients with you, say like flour, and then doing more elaborate cooking.
So not having our food already prepared, but actually kind of putting ingredients together to
actually
prepare a
doing
dish.
real cooking. Probably you're not going to do that 100% because it does take a lot more crew time. And so in that situation, it's probably going to end up being a mix of prepackaged foods and perhaps stuff
Okay.
that you prepare.
It's kind of like the cooking I do at home.
Right, exactly.
All right, great. Well, thank you. That's a wrap on the food wrap here and how it's wrapped here at NASA, the NASA Space Food Lab, again with Vicki Claris. From our kitchen to yours, happy Thanksgiving.